Most important topics in your module 4 of DTCO is that about interrupts. So usually they won't ask a single question on this. They'll always group the topics and ask you question like about explain about interrupt and its hardware, and they will also ask sometimes about how to enable and disable interrupts, and then handling multiple devices. Suppose they ask this all 4 questions for you, so it's like a good thing for you because separately they all are like very big concepts. So if you want to extend them, you can extend them like 1 to 2 pages for each topic. But if they have grouped this, they'll surely ask for 10 marks obviously, and you can write little from each point, and then aram you can fill 3 pages and write. So basically interrupts are now talking about in this subject. So what is an interrupt? You have to tell about this basic thing. And if they only half topic as like only 2 topics are interrupt and hardware, so I'll explain you what are the things to write and how to understand it. So you basically suppose you have some program in which it is being executed by the processor. Suddenly now the input output device needs some access to the memory. So now what happens is, so it will send a signal to the processor that it needs it will send a signal to that computer. That signal is nothing but interrupt itself. So at that, when interrupt occurs, so processor, it will halt the currently executing program, or it halts the program which is currently being executed in the processor, and then first performs the instruction which are sent by this interrupt. After the completion of the instruction, then only the processor will resume to the program which it was previously executing. So this is the basic idea of like interrupt, basic definition. If you read this, you will be able to understand even more clear. It is the hardware signal which alerts the processor when the IO device becomes ready. So here, what is the meaning of becomes ready means, usually either the processor will constantly check the IO device, that is nothing but your mapped input output. So if it constantly checks the IO device, the processor is wasting time in that, and instead of wasting that time, other things can be done. So that is your mapped output, input output, that mapped memory mapped input output. So in memory mapped input output, the processor will constantly check for IO device and it will waste time. But instead of that, it can also go for input output mapped input output. So in that, what happens? So the input out device itself sends a signal that it is ready. So after it sends a signal that it is ready, then only the processor will come and check and then give whatever perform the necessary task is done. So in this topic itself, the memory mapped input output is done, and also your input output input output is also done. So that also can be asked for 10 marks. So it has one diagram which I have not done here, so that I'll be explaining in other lecture. So here there are many situations where other tasks can be performed while waiting for an IO device to become ready. Interrupt signal is sent to the interrupt request line. So there will be a IR line connected common to all the devices. Whenever the device needs to raise an interrupt, it will just close its switch, and that switch will go to the processor and alerts that it needs a signal. So the routine which happens while responding an interrupt request is called as ISR. So you will be usually seeing this ISR. What is this? So ISR is about interrupt service routine. So the routine which is like in response to the routine which is executed while responding to an interrupt request. So that routine is called ISR, and the processor must inform the device. So when the interrupt has been accepted, right? So the processor should inform the device that its interrupt has been requested, because there won't be one single device. There will be more than one device. So to inform that device, there is so processor sends a signal, that is INTA signal. Interrupt. INT is for interrupt. Okay, this int is for interrupt. A is for acknowledge. So you will be having, you can also write IA, but here they have used INTA. So better you write INTA. There is also a word known as INTR, that in the IR and your INTR are both same. So you understood, right? So how interrupt sends like if the device is interrupt, it will raise a signal on the IR line, interrupt request line. So from that IR line, it will go to the processor, and if the request is accepted, the processor sends a signal INTA acknowledged, so to the device, so that it will be waiting for the processor to finish the task and send the required data. So there is an example for this interrupt over here. So the example is nothing but there are 2 programs over here. One which it is a normal computer routine. So and another is for the printer or display routine. So here as you can see, I is nothing but here this I indicates the interrupt. So while the flow of this program, there suddenly the device is requested for an interrupt. At this place, what happens is processor executing from here, it goes to this particular program executing this interrupt. So here whatever the instructions or whatever the things are done, after completing it, it returns back, the processor comes back to this position, that is nothing but I+1 position, and continues executing the program. So the same example in words it is been written here. In the program 1, when the interrupt is I is occurred, the program first executes the instruction I and loads the PC with address of first instruction of ISR. So inter service routine. So whatever the whatever the execution has been happened, the instruction. So executing nothing but we are executing an instruction. So the address of that first instruction is loaded to the PC. After the execution of ISR, means after the interrupt service routine completing the instruction, this whole thing after this is completed, so what happens is the processor has to come back to the instruction I+1. After this is coming, this is nothing but whatever happens here, the routine is ISR. After that I+1, so processor comes back to this place. So therefore when interrupt is occurred, the current content of PC is sent to some temporary secondary storage. So till here it will be having some content which has executed, so it will send to some temporary secondary storage, then perform this interrupt. After coming back from the secondary temporary secondary storage, it will retain the data and start executing. So the return at the end of ISR reloads the content of PC from temporary secondary storage. This causes the resume of I+1 instruction. So whatever this was happening, right, after that which has to happen, so it will get resumed over here. So this is the basic concept of interrupt. Now talking about the hardware for the interrupt. So as you can see here, this diagram is very important. Once you just learn by heart or practice this diagram, so this whole thing is all related to the diagram itself. So whatever we have over here, this much theory part, so I will be showing. So you have this till here, this theory part. So this all is all related towards your this diagram itself. So as you can see here, this is the processor part, and here the interrupt request line. So, okay, this is IR line is nothing but interrupt request line. This is the IR line, and this is one resistor, and this is the voltage across this line. So these are boxes are your multiple devices, and this line is nothing but your switch, and this is the grounds. So how to write this? So first what you have to say, all the devices are so you have to say that this INTR line is common to all the devices. So this INTR serves all the devices, and now what happened, the devices connected to the INTR line. So how the devices are connected to the INTR line? It is connected via switches to the ground. Switches to the ground you have to say. So this switches to the ground, so it is connected like that. Now what happens is, if all the switches are closed, so I mean open, if all the switches are open, there is no interrupt request sent to this IR line. So what happens is, so the potential difference across this line will be VDD, because there is no interrupt, right? So if there is nothing to interrupt here, so automatically the potential difference in this line will be VDD. Suppose if this device or multiple device raises request, so if the device has to raise the request, it has to close the switch, particular switch which is respective switch which is having, then only after the request is switch is closed, it will generate a request. So if a request is as made by the device, one or more devices, so what happens is, so the potential difference across this line becomes 0. So when the difference is 0, so here the whatever the output of this goes here, na. So here we have a NOT gate. So if it is 0, it makes it 1 over here in the processor, which means the processor will understand the request has been made, and it will start performing that particular instruction. So here there is this thing is nothing but an gate. So this box over here is known as gate, from which the interrupt requests 0 or 1 the output is entered. So either you can say it as open control collector or open drain. So this gate is called as that. So see here, the output of the open drain control is equal to the switch to the ground. So output of whatever is going here is equal to the switch of this ground. Till here I am talking, not after this. Okay, till here whatever the output is going now, it is equal to the switch to the ground. So obviously whatever this thing is sending itself will go there, right? So that is if it is open, if it is 0 only. Okay, if it is 0, it will open the gate. Since it is 0, it will open the gate. If it is 1, right, 1 or this VDD, it won't open the gate. So that's what it says. It's open when gate input is 0 state, and close when the gate input is 0 state. So the input from this whatever going from here, that means the indicates the state of this gate. If it's open, if any one of the switches is closed. If all the switches are open, it is closed. Okay, open means what? If it is 0. Close means what? If it is 1. So that's what you have to know about this interrupt and its hardware. So that's all for this topic.